Hello everyone. So if you've already watched my previous video on non-calculator techniques, this one is the perfect follow-up. And today I'll be working through the specimen paper for 2025 exams. This is non-calculator and this will be split into 3 parts. And this is the first part. So please stay tuned for the rest. So let's get right into it. And already we're seeing something new here with the papers. They give you a list of formulas to help you with the exam. But remember that this is a non-calculator exam. Okay, so the first question, work out 0.01 squared. So the way I would do this is convert 0.01 to standard form, so something like this. So 1 times 10 to the power of -2, and then squared. And then this is equal to 1 squared multiplied by 10 to the power of -2 squared. You square each of the terms individually. So this is equal to 1 times 10 to the power of -4. And that's our answer. Or if you wanted to give in decimal form, the equivalent of this would be 0.0001. So that's our answer for the first one. A fairly straightforward mark. The next one, write 57, this number to 4 significant figures. So what that means is 57.3. And now to fill in this last figure, we look at the value after 3. It's 9, which is greater than 5. So if it's greater than 5, you increase 3 by 1. So this changes to 4. And then the 9, you also increase that by 1, so 57.40. So you're rounding up to 4 significant figures. So 57.40. That's the first 2 questions done. Now for the next one, it's a conversion question. So we're changing 250 euros into dollars. And 1 euro is $1.10 dollars. So if we know that 1 euro, this is the way I would like to, this is the way I would lay it out. It just makes it easier for myself and the examiner. So if you want to calculate what 250 euros is in dollars, you do, to get from 1 euro to 250, you multiply by 250. So you do the same, exactly the same on the other side. $1.1 multiplied by 250. And remember that 1.1, now this is where your mental math skills will really come in handy here. This is why in my previous video I've recommended you to familiarize yourself with non-calculator techniques like this. So a good technique I'll do for this question, I'd recommend, is to split this up like this. 1 multiplied by 250 plus 0.1 multiplied by 250. Because if you expand out, it will just give you 1.1 multiplied by 250. So this, of course, is equal to 250 plus. Now 0.1 multiplied by 250 is the same as saying 1/10 multiplied by 250. And 1/10 of 250 is just 25. And then the sum of that is $275. So hence 250 euros is $275. To write that here, 275. Okay, now we are given 2 triangles. ABD and ADC. And BDC is a straight line. So whenever you hear a straight line in your exams, there should be a trigger word for you to cast your mind back to angles on a straight line add up to 180. So they've given us these angles, and we are asked to find angle DAC, which is this angle right here, DAC. So go back to the trigger word of straight line. So angles in a straight line add up to 180. So therefore, this angle right here, ADB, is 180 minus 81. Here, another part where your non-calculator skills will come in handy here. This is just 99. And then, if we look at triangle ABD, the angles in a triangle add up to 180. So therefore, angle DAB is equal to 180 minus 61 minus 99. And so, angle DAB here is equal to 20 degrees. So now, we're given that AB, the side length AB is equal to side length AC. So then, the entire triangle ABC, so this triangle ABC is isosceles. And in isosceles triangle, the base angles are the same. Hence, this angle ABC is equal to angle ACB, which is therefore going to be equal to 61. And now we can finally work out what angle DAC is. DAC, now if we look at this triangle, angles in a triangle sum to 180. So angle DAC is equal to 180 minus 81 minus 61. And here you need a non-calculator skills again. But after you evaluate this, you get an answer of 38 degrees. So this is 38 degrees. And so our answer here is 38. Okay, so on to the next question now. Now we're asked to convert 0.17 meters into centimeters squared. So the way I would lay this out is, we know that 1 meter is equal to 100 centimeters. And now if we square both sides, 1 meter squared is equal to 100 squared centimeters squared. So we're squaring both sides here. So that would give us 10,000 centimeters squared. All we've done here is squared both sides of the equation. So therefore, 0.17 meters squared is equal to, now remember this, the same thing that I did above here with the conversion of the euros to dollars. We did the same thing here. So to get from 1 to 0.17, you multiply by 0.17. And then you do the same on the other side. And 10,000 centimeters squared multiplied by 0.17 is just 1,700 centimeters squared. 1,770 centimeters squared. So our answer is 1,700 centimeters squared. And that's that part done. Now, we're given the mass of a object is 4 kilograms and the volume is 600 centimeters cubed. Calculate the density of metal, giving our answer in grams per centimeters cubed. So we should always pay attention to bolded words in questions. The reason why this is bolded over here is because they've given it to us in terms of kilograms, here 4 kilograms, but they're asking us for grams instead. So the first thing you should do is just convert it. So 4 kilograms is equal to 4,000 grams. And so the density is equal to mass over volume, which is now 4,000 grams divided by, we're given the volume 600 centimeters cubed. And now, a way I would recommend to simplify this and calculate it without a calculator is to divide both sides by 100, which means that the 100 cancels out here, because there's a common factor of 100 on numerator and denominator. So now this becomes 40 over 6. And 40 over 6 is much easier to calculate, as you can give it as a mixed number or mixed fraction. So 40 over 6 is equal to 6, or if we simplify this first, 20 over 3. And 20 over 3 we know as a mixed fraction is equal to 6, because 6 times 3 is 18, and there's a 2 remainder. So 6 and 2/3 grams per centimeters cubed, and we can leave it as that. 6 and 2/3 grams per centimeters cubed. Okay, now we have a vectors question. Find the vector u minus 2v. So what we do firstly is we find out what 2v actually is. And so the way we do this is just multiply each of the numbers in the vector by 2. So at the top, negative 12 times 2 is negative 24. And on the bottom is 10. So that's negative 24, 10, 2v. And so u minus 2v is equal to 3 negative 2 minus negative 24, 10. And that gives us an answer of, the way we do this is just treat it like one line at a time. So first the top, so 3 minus negative 24. Remember, 2 minuses make a plus, so this is 3 plus 24. So then it's 27 on the top, and on the bottom it's negative 2 minus 10, which is just minus 12. And that's our answer for that one. 27 minus 12. Now we're asked to find, and if you notice here, the reason why I'm putting a little squiggly line under each of these letters is to differentiate it from a variable, because here it's being used as a vector and not a variable, which is why it's good practice to include the squiggly line under these letters. And now we are being asked, this notation is to find the magnitude of the vector v. And the magnitude of a vector is basically its size, like how great it is. So the way we do this, if we imagine vector v, it looks something like this, like that. It goes 12 units in the left, so negative 12 here, and 5 units up. And if we want to calculate the magnitude of this, if we notice, now we have a right angle triangle with, so what we can do is the magnitude of the vector v, all we have to do, the general formula is just take each of the components of the vector and square it. So negative 12 squared and then plus 5 squared. And this is equal to, you should be familiar with this Pythagorean triple, but if you aren't, you can do a quick calculation here. Negative 12 squared, remember the negative sign goes away after you square it. So 144 plus 25, which is equal to the root of 169. And you should know, if you remember from the previous video, non-calculator video, I mentioned the importance of knowing your square numbers. And here this is equal to 13 squared. So root of 169 is just 13. So that's our answer for this one, 13. Okay, now we're on to question 8. So we're given a semicircle with diameter 9. Calculate the total perimeter of the semicircle. So the perimeter of a circle is 2 pi r. But here we only have half of a circle. So if we want to calculate this part right here, we have to divide this by 2. But remember, the perimeter, we're asked for the perimeter of the semicircle, and not just the arc length. So we also have to include this diameter of 9 centimeters. So 2 pi r plus 9 is our formula for this. And now we know r is just diameter over 2, so it's 9 over 2 equals to 4.5. So therefore, before we substitute the value of r, we can simplify it by cancelling out the 2's. So we're left with pi r plus 9, and r is 4.5. So this plus 9, and this is just equal to 4.5 pi plus 9. And we are leaving our answer in exact form. In the previous video on non-calculator, I talked about what exact form is. And so here we're doing just that. We're leaving it in exact form. Because obviously we can't simplify it without the calculator. So our answer is just 4.5 pi plus 9. Okay, so now in the next question, we're given this sequence and we're asked to find the fifth term in the sequence. This is the notation used for a fifth term. So the way we do this, we just calculate the common difference. And as you can see here, all we have to do is subtract from 5 to get to the next term. So to get to t5, we just have to subtract 5 from t4. And therefore the answer would be -3. And that's just it. Now if you want to find tn, basically it's asking us for the nth term. Nth term. And I have a few videos on finding the nth term, but this is an arithmetic sequence. So to find the nth term of an arithmetic sequence, all we do is write the common difference first, -5, and then multiply it by n. And then to find the constant term, all we do is calculate t0, or the 0th term. In this case, t0, what we do from t1 is to add 5. We're going the opposite way. So it's 22. Because if you go, we're still following the rule of subtracting 5 every term. So the answer is just 5n plus 22. -5n plus 22. And that's our answer for the nth term. Now here we're adding two mixed fractions. So the way we do this is first convert both to improper or top-heavy fractions. So you should know how to do that. If we convert 2 2/3 to an improper fraction, that will just give us 8/3. And then if we convert the next 3.5 to an improper fraction, that will give us 7/2. And now we should convert both to the same denominator. And the common the common multiple, the lowest common multiple of 3 and 2 is 6. So we convert both to a denominator of 6. We get 16/6. Multiply both sides of this fraction by 2. And then plus 21/6. We multiply both sides by 3. Both the top and the bottom. So then this gives us 37/6. Which gives us 6 and 1/6 as a mixed number, because 6 times 6 is 36 with a 1 remainder. So that's our answer, 6 and 1/6. And now we're asked to find the value of this right here. So if you cast your minds back to, it's actually this was a part in my formula booklet. And in the indices section, the way to do this is that we can rewrite this as cube root of 64 squared. But 64 squared is still a big number to calculate without the use of a calculator. So to make it easier, we could take the squared out and do it like this. Which is much nicer to work with. And the cube root of 64 is 4. You should know that. And it's helpful to know your cubes. This is the reason why. And 4 squared. So then the answer is just 4 squared, which is just 16. So our answer for that is 16. Okay, now we're on to some standard form questions. We want to work out the value of 7.1 multiplied by, we want to work out the value of these. So the way we do this is just do 7.1 multiplied by 2 multiplied by 10 to the power of 15 times 10 to the power of 3. Notice the overall expression hasn't changed. We're just moving the terms around to make it easier to work with. Because now 7.1 times 2 is 14.2. And here we can evaluate this as with using the indices rules, which again is in my formula booklet. And to multiply indices, you just add them. So it becomes 14.2 multiplied by 10 to the power of negative 12. But remember, we're not done yet because in standard form, this number right here must be between 1 and 10. So 14.2 is too large. So what we do is we do it like this. 1.42 times 10, because remember, 1.42 times 10 is just 14.2 times 10 to the power of negative 12. And now again, we have another pair of indices, which we can deal with by just adding. Remember, 10 is 10 to the power of 1. So this is 1.42 times 10 to the power of negative 11. And that's our answer for that one. Now for the second part, we want to find 5.2 times 10 to the power of 7 plus 5.2 times 10 to the power of 6. So now notice that the sign has changed. It's not a multiplication sign anymore, it's plus. So we can't do the same method as before because now we're not multiplying by indices. So what we instead do is convert them both to have the same power of 10. So we could convert this right here, 5.2 times 10 to the power of 6, to a constant multiplied by 10 to the power of 7. So then that is just, if you do the same method as above, we can split 5.2 as 0.52 times 10. So 0.52 times 10 times 10 to the power of 6. And that's equal to 0.52 times 10 to the power of 7 after we add up these indices. So now we have 5.2 times 10 to the 7 plus 0.52 times 10 to the 7. So now if you want to make this easier to work with, if you let x equal to 10 to the power of 7, what we essentially have now is 5.2x plus 0.52x. And if you add these up together, you'll get 5.72x. But remember, you have to replace x by 10 to the power of 7. So this is equal to 5.72 times 10 to the 7. And that's our answer. It is in standard form because this constant term here is between 1 and 10. So yeah, 5.72 times 10 to the power of 7 is our answer for that one. Okay guys, that will be it for part 1. That's it for part 1. Part 2 is coming very soon, so please stay tuned for that. And I'll finish the rest of the paper in the final part. So if this video was helpful, please remember to stay around till part 2 and part 3 where I go through the entire paper. Thank you.